Okay, so today we're going to be working out of the Unit 5 Systems of Equations packet. We've been in that for a while. Turn to page 13. It's not labeled, but it looks like this. I kind of messed up the first video, so I already have it filled in. But we talked about in class when you have two unknowns, you have to have two equations to solve it. And so we call that a system. This is just a different way to explain it. So a pair of linear equations with the same variables is called a system of linear equations. The solution to the system is a pair of values that satisfies both equations. So remember, we listed it as a point, an ordered pair. For most systems of linear equations graphed on the same axes, the lines intersect at one point. So that's most of the time. Okay, this point is the unique solution to the system because it is the only point that is on both lines. The x and y coordinates of this point will satisfy both linear equations. So if we check it, remember we did the double check, it will check into both. Lines with the same slope and different y-intercepts form parallel lines. So this would be like if the gym, remember we said they charge the same for the session amount, but the membership fees are different, and no matter what I did, the one gym would always be more expensive no matter what. That's going to be this case where we had shown this and talked about this before, saying there's just never going to be a situation where this gym is cheaper. So you wind up with parallel lines. They'll never intersect. There's never going to be a time where this would be cheaper. If the two lines are different forms of the same line, so basically you're presented with a line, it looks like they're different, but when you go to rearrange it, they're the same. They're going to overlap, and there will be infinite number of solutions. It means the gyms charge exactly the same way. So here's basically our three options. You're going to see that most lines will, in most situations, you're going to intersect, but you'll occasionally find times where they don't, and sometimes they're the exact same situation. So without graphing the linear systems below, tell whether the system has one solution, no solution, or infinite many solutions. Explain how you know. Well, if you look at these two here, and this is not unfamiliar to you, they have the same coefficient, right? So that means their slope is the same, kind of like here, but they have different y-intercepts, meaning they're charging the same rate, but maybe the initial value is the same, or is different. I'm sorry. So this is going to be no solution. Why? Because it has this. They have the same slope or same coefficient of x, right? And they have different y-intercepts, different constants, right? Same idea. Ooh, intercept. So we did this in class the other day. Oh, you want to be able to see the video? To see what I'm doing? Should probably put that on the video, right? Okay, so these have the same slope. It's going to look very similar to this right here. Okay, and then the next one, you can see that they have different coefficients or different slopes, so you're going to get a solution, right? So this is one solution, and they have different slopes. Looking at this, I can tell they're going to intersect at their y-intercepts. And then the last one is a little tricky because you can't answer these questions or, pick this apart if they're not in slope-intercept form most of the time. Where's my little sheet? So, there's a couple ways you could do this. For me, the way Mrs. Raymond would do it, because I've been practicing forever, is I would recognize that I would just divide everything by 3 up here, and I would see that I would get the same exact equation up here as I did down here. It would be y plus 2x equals -3, and oh, they're the same thing. If they're the same exact thing, you're going to have infinite solutions. Some of you won't recognize that so easily, so you're going to have to take each one and solve for y. This is the lesson notes that we have step-by-step notes from lesson 3, I think. So let's take this one. We're going to rid the x term, so minus 6x once on each side. Then you're going to rewrite 3y equals I'm going to put this one first because I like it there. And then I'm going to put this one here. Remember, they are not like terms. And then the last step is to divide by the coefficient of y. So rewrite, you get y equals negative 2x minus 3. So this one right here, y equals negative 2x minus 3. Right? So when you put it in slope-intercept form, that's what it looks like. Let's do the other one. We're going to subtract 2x once on each side. I'm going to get y equals negative 2x minus 3. And boom. They're the exact same line. So you're going to have infinite solutions. Because they have the same slope and same y-intercept. Everything's the same. Makes sense, right? So we've already talked about this in class. This is just more of a formal way of writing it down into our notes. Make sure you're solid. And then what I'd like you to do right now is pause the video and try the next two problems that says lesson 4 homework. I want you to go ahead and try those, and then we'll come back. So pause it. Come back. Okay, you're back. Look what I did the first time. So I go to graph this, and my ruler is kind of weird. It's got this like weird little edge thing. And I didn't do good graphing the first line, so when I actually graphed these, I see that they're not parallel, so you can see eventually over time they would intersect if this was graphed properly. I knew by looking at the equations that because they have the same slope and different y-intercepts that they should be parallel. So that was that piece of math that you have to pull in that this was not reasonable, right? Checking your answer to make sure it makes sense. So I immediately redid it and got this for an answer. So you want to make sure you're pretty accurate with your ruler, and I usually just try to make like more than 2 dots, and then I try to make some on either side of the y-axis. So your y-intercept was 0, your slope was 2. The y-intercept here is negative 4, slope was 2. So these lines will be parallel, which means they will never intersect. This system of equations has no solution. Then I took this equation, I rewrote it here. It is y equals 4x plus 8. So you had to add 4x to both sides to put it in slope-intercept form. This y-intercept is 8 and the slope is 4. So a little bit of a new thing here. When you put your y-intercept in and you want to go up 4 over 1, it doesn't fit on the graph. So remember, you can either go up and right or do the complete flip opposite and go down and left. Double negative motion makes a positive, right? So you can go down 4, left 1, down 4, left 1, and you'll still wind up with your positive incline, right? So this is the line y equals 4x plus 8. And this one here, you want to distribute before you answer any questions about slope and y-intercept. That gave me, and like, woohoo, y equals 4x plus 8. I have the same exact line. So this would be an example of infinite solutions, and that makes the end of this video for today. I think you're doing a really great job, and I'm very proud of you. So have a good day. Check Google Classroom for the assignments. There's some exit tickets. Okay, see you next time.